take a look at what it takes to find the rate in an exponential model. So first off, our exponential model that we're using is p sub n equals p sub 0 parenthesis 1 plus r to the n. The information that's given is there's a certain number of people in 1997. So the initial value, we had 2.12 million. We do not have the rate. And 9 years later, so after n equals 9, the final population will be 2.53 million. So the only variable left over is r. We need to solve for r. The first step is a pretty simple one. We divide by the coefficient of this exponential and recognize that the millions reduce. We could have also moved the decimal place 6 places to the right, but the millions as a unit reduce as well. So I'm going to leave this, since we have to use our calculator anyway, 2.53 over 2.12. I will not get an approximation yet. So we have 1 plus r to the 9th. Now, how do we get rid of the 9th power? To solve for the rate in an exponential model, we end up using a root. We need to take the 9th root. Now what the 9th root is the same as a 1/9 power. So whether you write the 9th root over both sides or a 1/9 power over both sides, they are equivalent. Some people don't have a xth root button on their calculator, so this 1/9 exponent is a little bit nicer. Now what the root is literally a 1/9 exponent. And 9 divided by 9 is 1. That's how the root is able to eliminate the exponent. So we have 2.53 over 2.12 to the, I'm going to put a parenthesis around this exponent. This will make it easier for us to calculate it with a calculator. This equals on the right side 1 plus r. Now there will be some problems that ask for 1 plus r, which is the growth multiplier or the there's other names for it. That's the one that's coming to mind now. But we want to solve for r. So our last step is just the subtract 1. So we have r equals this term, 2.53 over 2.12 to the power 1/9, all minus 1. So on a calculator, left parenthesis 2.53 divided by 2.12 all to the power parenthesis 1 divided by 9. This will be the 9th root. And then minus 1. We have 0.019839, etc. R is approximately 0.019839. And it goes on forever, but we have more digits. And we look at the instructions and it says express the growth as a percentage and round to the nearest hundredth. Now since they're telling us percentage first, this hundredth is actually 100th of a percentage. It's not the best instruction, but if we go to a percent, moving the decimal twice to the right, or in a calculator multiply by 100, we get 1.9839%, and then to the nearest hundredth, r equals 1.98%. And that would be our final answer, which matches up with the key. I hope this makes sense. To solve for the rate, you use a root.